Hello and welcome to this tutorial on our project about building a text classification workflow using KNIME. In this session, we will walk you through the step-by-step process of analyzing and categorizing Google Play Store reviews of the Instagram Lite app using KNIME's powerful workflow automation. Before we dive into the implementation, let's first understand why we build this workflow and what we aim to achieve. Every day, millions of users post reviews about mobile applications on the Google Play Store. Some reviews are positive, others are negative, and many provide valuable feedback about bugs, user experience, performance issues, and new feature requests. However, manually reading and analyzing thousands of reviews is time-consuming. Instead, we can automate this process using a machine learning-based text classification model to categorize these reviews efficiently. In this project, we have collected reviews of the Instagram Lite app from the Google Play Store. Our goal is to build a supervised machine learning model that can classify these reviews into good or bad based on their textual content. By the end of this tutorial, you'll understand how to import and pre-process textual data, convert text into numerical features, train and evaluate a classification model in KNIME, automate and visualize your workflow. So let's get started with our methodology.
Before we jump into the live execution of this workflow, let's first understand the methodology. So this workflow is classified into 6 stages: data scrapping, reading textual data, enrichment, pre-processing, transformation, and classification. So in the data scrapping, we scrap data from Instagram Live in the Google Play Store. So the extension that was used was Data Scrapper in Chrome. First, random sampling was done to split training and testing data. So this is the training data where we have 1200 data for training the dataset, and this is the testing data, which are unique 60 data other than the 1200 data given for the training. So continuing, after data scrapping, there is the reading of textual data. So we start by reading reviews from the Excel file. The data contains user feedback, which we need to pre-process before training our model. So followed by reading textual data, there is enrichment stage, where we use parts of speech tagging to understand the grammatical structure of the text, which can be useful for feature extraction. So following this enrichment stage, we have pre-processing stage. This is a very crucial step where we can clean and standardize the text. This includes removing numbers and punctuations, filtering stop words, converting text to lower cases, applying stemming to normalize words. So followed by pre-processing, there is a transformation stage. So where we convert the text into numerical features using the bag of words model and term frequency. This transformation allows us to train machine learning models. So coming to the last stage of this workflow, it is the classification stage. So we train a decision tree model using the transformed text data and evaluate its performance using metrics like ROC curves and accuracy scores. So now that you have an overview of the workflow methodology, let's dive into data scrapping in KNIME and execute this workflow step by step.
So now that we have taken Instagram Lite as the app here, so firstly we have come for the Google Play Store, and here in Instagram Lite app, we can scroll down so that we'll get the ratings and reviews. So here on clicking this arrow mark, we'll be able to get all the recent reviews on Instagram Lite app. So already we have the Data Scrapper extension installed in our Google Chrome. So clicking on this one, it will take us to the data scraper. So this would take us a while to get into the data scraper. So what we are planning to do here is that we are going to scrape the details from this Instagram Lite reviews. So first we'll have to click on this scrape this page so that it opens up the data scraper, and in this one we can create a new recipe. So on clicking this new recipe, it will take us to another screen. So in this screen we'll have 6 tabs. So initially it is the type. So here we will be getting the scraped data in the form of a list. So list is getting checked here, and then after this we'll be getting into the scrape tab. So where we'll be getting 2 steps. One is the rows and the other one is the columns. So on clicking the rows, so here we'll be able to select the number of rows of data that we need to scrape. So in order to do this one, first we'll be clicking on the easy row finder. So on clicking this one, so as you can see here, so first we can select the first row and the second row, and ultimately it will select the entire set of rows from this Instagram Lite app reviews. So here let me click on the, so first initially on clicking one name, we'll have to click 1, and for the second name we have to click 2, so that we will first select the first set of rows. So here, as you can see in this one, the first set of 20 rows are being selected. So then here we can click on confirm. So after this we'll have to go to the column step. So in column step, we can choose the number of columns that needs to be added from this data that we are scraping. So in this one, we can click on add new column. So we can name all these columns that are possible. So firstly, let me name the reviewer name, and then click on this easy column finder. So here I can click on this reviewer's name and click on C, so that this is the preview that we are getting it here, and we can click on confirm. So similarly, we can add a few more columns that are possible. So I'd be adding up all these columns. So the next one is the review text. And the next one is the review date. Next one is the ratings. So for ratings, we'll have to choose the other attribute in order to take the ratings. So here, we can take the rated in area label format. So we'll get the ratings, and finally the helpful review. So done with this one. So after this one, we can just go to the save tab and we can give a name as recipe TANP here, and we can save this one. So once this is getting saved, we can scrape this in the data miner. So once we get into this data miner, we can go to the recipes that are created. So it will take a bit of time to load the recipe that we have created. And once we have created the recipe, we can just go and directly, here it has come. So in this one, the recipe, we can scrape the data, and here the 20 rows are available with all the columns that are created. So we can download the data in the Excel file, and then we can use this for our workflow model.
So once the data scraping is done, our input data is ready. So we have training and testing data get ready with us. Let's dive into KNIME Workspace. Here, as you can see, the first step is the Excel reader, where this node is used to read the Excel file which we have already extracted from the data scraper. Next, we added a new node called Rule Engine. In Rule Engine, what we did is we converted the reviewer rating column into a category based column like good or bad. If the text contains 1 star or 2 stars, it is categorized as bad. If it has 3 stars, 4 stars or 5 stars, it is categorized as good. So in the review ratings columns, you can see only two values like bad or good. Once this node is applied, our output will be shown like this. As you can see, review rating is turned like this. Previously, from the Excel reader, it is given as rated 5 stars out of 5 stars. Now, with the Rule Engine node run, we have got the review rating updated as good or bad only based on the review ratings. So next is the document creators. Document creator is essential to convert all the values into a structured format so that we can do all the other processing which is followed by one another. First, the row is filtered if you have any missing values to handle the missing problem. Next is the string to documents, wherein which every document is converted into string. Here, every string title is named after the review rating, which is corresponding to their input. Next, text will have the review text. Then the categories are used from the same review rating column. And we have dated today as the date of the job done. So this is how it goes. Once the string document is generated, you will have the new column called document, wherein which the document title and the document have been uploaded in the same title itself. So next is a column filter, wherein which we will be having only document in one side, and we will be removing all other column names in the other side, because we need only document to process further. So once the document is filtered, the job of this document creation node is done. So after this, we'll be go for the POS tagger, wherein which we'll be tagging each POS statements. So in the POS tagger, we'll be using OpenLLP English Word Tokenizer to tag the POS. Next, we'll be doing the pre-processing. So in this pre-processing, we have a sequence of nodes aligned in it. So first is a number filter, wherein which we'll be removing the numbers in it. Encast to limit the length of the characters, we have limited to 3, as you can see here. Then punctuation eraser to remove the punctuations. Stop word filter to remove all the stop words in the reviews. Case converter to convert everything to the lower case, as we see it is selected as 2 lower case. Then snowball stemmer to convert all the words into their root words, like for example classification into classify, like that. So everything will be stemmed based on this using this snowball stemmer. Then tag filter is used to filter out adjective, nouns and verbs only. So all the abbreviations have been selected accordingly so that they will be filtered and used for the future processes. So this whole sequence is done in the pre-processing meta node area. So once the pre-processing is done, our output will look like this in the output column. There is a new column called pre-processed documents, wherein this empty string is named as title, and inside every other process which have been done previously has been displayed within this title. So next is the transformation stage. So in the transformation stage, what is it doing is it's just creating bag of words and creating the document vector for it. So in bag of words, what it does is it generates wait a minute. So the output of the bag of words will look like this, wherein which, so in every row, what all the terms has been used with tagged POS will be displayed in this bag of words creator. So the document and pre-processed document columns are used for this creation. Then next, term frequency is calculated, wherein which in each row, what all the terms has been extracted through bag of words, their frequency will be calculated in the new column and appended in here. Document vector simply, what it does is it creates one column for each words, and it will update all the document into vector mode like this. In row 1, when of NT media are present, whereas 10 to 15 when else are not present, wherein which in row 2 it is present. Like that, it will create document vector for each row's data. Next, document data extractor node, what it does is it extracts the category only from the notes. Like for example, we have already classified as a string to document. We created category from the review title, review ratings. So we use that category alone as a data extracted and use it for the further prediction. So from the transformation stage, there will be two outputs will be generated. So I will come to the second part. Second part now. So all this process will be done only for the training dataset. Why? Because the training dataset included in that. So we have to include testing dataset also to create the decision tree prediction. So there is another line called decision tree, wherein which we'll be doing that. So we'll be zooming out. We'll get two Excel readers, one for training, another for testing. So in this testing Excel reader, we'll use the same rule engine to calculate to convert a category of the review rating. Then document creation same will be replicated for creating the document, and POS tagger and pre-processing are all same with respect to the training and testing. Now in here we'll be just using bag of words and TF just before we create a document vector applier. So once the bag of words and TF for the testing dataset is created, we'll be using document vector applier to merge these two. So output from the transformation of testing training and TF of testing will be compiled in the document vector applier, so that the number of columns have been increased, as you can see. Next, we'll be categorizing it. So before categorizing it, we'll be coloring the variable. So in the color manager, the category variable will be based on two colors, good and bad. Bad is red and good is in green color. Here also we'll be using the color manager, but we'll be using document data extracted before applying this. So in document data extractor, the same category is extracted and used for color manager. So once color management is done, here in this column filter in the training row, only document is excluded and all other terms are included in this, so that to create a document prediction. So decision tree learner has been given input for this, wherein which we'll be using gain ratio and no pruning to do that, and all of the settings have been set as per the prediction models. So once the prediction is done, we'll be getting a decision tree which can be viewed using decision tree JavaScript. So coming back to the decision tree, once the decision tree is done, the decision tree can be viewed using decision tree view JavaScript, so that it will be having a smooth animations. So here you can see the bad is categorized like in the given data table. We can see if the nice is present, it is good. If it is not present, it will check for the root words related to smoothly. And if it is present, it is good, or else it will go for somehow. Like that, it goes for each and every root word, and it will give you whole the decision tree for this. So once this is done, the model is done, but we have to check whether the model is performing good or not. So for that, we'll be using testing data from that. So in the below row, we'll be having all the testing data files. So from the color manager output, we'll be giving it as a data predictor, where which we'll use the model created from the training data to test the data from the testing data file. So this decision tree predictor will give the final output from this. So the model is done, the prediction is done, but we have to evaluate the model whether the model is performing good or not. So we are in this workflow, we'll be evaluating the model in two means. One is by showing the confusion matrix using scorer node, and the other is using ROC curve. Let's see one by one. First, in order to see this run the scorer node, we need three columns in particular. So we'll be using column filter to use those three columns only. So in the column filter, we'll be using document, category and production category columns. So this will give you the scorer node output. Wait a minute. This is a simple confusion matrix having actual versus predicted nodes. So the scorer JavaScript node will give you the more enlightened version of the confusion matrix, giving the actual versus predicted, and also the specificity, precision, accuracy, specificity, and everything will be displayed along with the class statistics and overall statistics in the JavaScript node. So once the scorer is done, we'll be having the ROC curve. So in order to have the ROC curve, we have to plot it. So the x and y axis have been selected like this. First, the actual is in the x-axis with the values from the category column and only good values, matching with the predicted category column equal to good, which is from the y-axis. This plot gives you the AUC value of 81.2, which is 81.2% the model is predicting the sequence correctly. So any future reviews will be predicted good. So as this value lies between 80 to 90%, this model can be classified as good model. The next question comes whether this model is applicable only to Instagram Lite reviews app from Play Store. The answer is big no. This model is a very generalized model which we can use to get review classified for any application. Say for example, instead of Instagram Lite, we can use Facebook Lite or any games in particular. We can use the same data scraping technique to extract the reviews from the Play Store app, and we can split them as testing and training. Like first row is for training, second row is for testing. If we give these data as input, the model will predict the reviews and it will give you the structured data predictor table as shown in the workflow. So this model is not listed for only reviews, it can be used for any other thing. So our project's ultimate motive is to create a generalized model which can be used to classify the reviews accordingly. So this comes to the end of this video. So if you like this video, please like, share and subscribe. Thank you. Bye. Cheers.